Hello viewers, welcome to my channel. Apart from my regular subject teaching, I also plan to discuss a few important questions that appeared in the previous competitive exams conducted nationwide and statewide. My discussions will cover exams like CSIR-UGC-NET, GATE, TIFR, IIT JAM, and some state level examinations like SET, SLET, or degree lecturer, polytechnic lecturer, and many other exams. With respect to these questions, you will get a holistic approach towards the topic. When I say holistic approach, the discussion will not be in part but as a whole, and this is my promise. So whatever be the question, I'll just get deep into the topics and we'll have a discussion. So let's begin our journey with a question from Bioinorganic Chemistry that has appeared in CSIR-UGC-NET December 2011 for 4 marks. The question is, in bacterial rubredoxin, the number of iron atoms, sulfur bridges and cysteine ligands are. Options have been given here. So before getting into the question directly, what is rubredoxin is an iron sulfur protein. So the general name given for these iron sulfur proteins which carry electrons is ferredoxins. I am writing the name by breaking it. Ferredoxins are iron sulfur containing proteins. It is broken down into fer, redox, ins. Fer refers to iron, redox refers to reduction and oxidation, and ins refer to proteins. So these iron sulfur proteins will carry electrons, and these are non-heme proteins. There is no heme portion within this, it is only a proteinous backbone. Also there is a reduction and oxidation kind of a reaction that occur within these proteins. Since they carry only one electron at a time, usually the switch on in the oxidation state will be from +2 to +3 or from +3 to +2. The general representation for these iron sulfur proteins is N iron and M sulfur, where an asterisk is given. So for all these ferredoxins, there are two different types of sulfurs. One is called as an bridging sulfur or bridging sulfur. The another one is a cysteine sulfur. So when I say a bridging sulfur, there is other name given to it. It is also called as a labile sulfur, or you can also call it as an inorganic sulfur. So why are we calling it as a labile sulfur? That represent with respect to its reactivity, or you may also call it as a bridging sulfur or an inorganic sulfur or a sulfide. The second type of sulfur is a cysteine sulfur. It is also referred to as organic sulfur. Usually it is called as a non-labile sulfur because with respect to its reactivity towards a mineral acid, it is very much non-labile. N could be any number, M could be any number, that depends upon the type of the iron sulfur protein. For the case of rubredoxin, we find that there is only one iron, whereas the number of bridging sulfurs are found to be 0. So the labile sulfurs are 0 and there is only one iron. So a ferredoxin with only one iron and 0 sulfurs which are inorganic, such a ferredoxin is called as rubredoxin. Why it is named as rubredoxin? Because it is having a red color. So the single iron and a single electron carrier which is having a red color is referred as rubredoxin, and it is abbreviated as RD. So we got our answer that rubredoxin has only one iron and 0 labile sulfur. So the option must be D. Also let me give from which bacteria that these are isolated. One of the bacterium is Clostridium pastorianum. This is one bacterium, and one more species is Pseudomonas oleoverans. So from these two, rubredoxins have been isolated. Well, this is up to our question discussion. Now from my side, I am posing a couple of questions. For this rubredoxin, which is red in color, which is a single iron tetrathiolato protein, when we say tetrathiolato, 4 cistenyl sulfurs are present. My question is, how many peaks you can see in the Mossbar spectra and ESR spectra? Also, what is the symmetry point group for the active site? So to get the answer, you can switch on to my next video to have an idea about the geometry so that you can work out its symmetry point group. I am drawing the structure. One iron is attached to 4 cistenyl sulfurs. And iron can switch on from +2 to +3 and +3 to +2. We call it as a redox protein. Well, this is our discussion. Thank you.